Good morning, students. Today we are again having another practical of biochemistry subject, that is to study the colorimeter and demonstration of it and its components and uses. As you know, this is a colorimeter, digital photocolorimeter, and it is used for determining the concentration of various analytes, means various components, chemicals in our body fluids, such as serum. In serum, we know we have to measure the amount of glucose, cholesterol, uric acid, HGPT, HGOT. So for all enzymatic and endpoint reactions, we use this colorimeter. So today we are going to study this colorimeter, and we will see what are the components, what are the principles on which this instrument is working. So first of all, let me introduce you quite different components on which this colorimeter is working. So when we switch on this instrument, the light is generated because there is a bulb inside. Now that bulb will produce some rays of light which will go and will fall on filter first. So filter, what is the function of filter? To get block all other lights, rays, and pass only the color which we are interested in. So if we want green, then that green filter is there. So it will pass only green light through that filter, and that pass light will fall on cuvette. Now cuvette is the test tube where we have put the reaction mixture or reagent for which we want measurement. So when that ray will fall on cuvette, some of the light will absorb by the concentration of glucose or whatever analyte in that reagent, and remaining part will pass to the photocell. Now photocell, when rays will hit the photocell, the light energy will convert it back into the electric energy, and this electrical energy will be giving us readings that we call absorbance. So you understand absorbance, okay? So this absorbance is very important. So Beer and Lambert law states that this absorbance is directly proportional to the concentration of analyte and path of light. The path of light is generally the diameter of cuvette, that we remain constant, that we keep constant. And other things that we see, that for example, if you are measuring the glucose solution, you know, after adding the reagent and adding the sample means patient's serum, when we add it creates some pink color. Now if you check it with your naked eyes, that color, you can see whether it is a faint pink or dark pink. So we can understand that if it is a faint pink, then his blood sugar is normal or low. But it is very dark, then we can say that it is high sugar, above 250 or like that. That is abnormal sugar. So that measurement is taken by this instrument very accurately. Okay. So this is the function of photometer, and this is the principle that I have explained. Now we will see a little bit closer its components and how to use it. First of all, we have to switch it on here. We have to switch it on. Then we have one switch here. We have this switch here. Okay. After that, you can see there are two buttons given. So it is auto 0 button. You put the distilled water here and then put 0, so that the result will blank, and when you put the color solution, the results will change, so that you will note down. So this is the filter wheel, and there are total 8 filters here. you can just rotate this wheel like this, and you will select whatever filter you want. So in this way you can change the filter and you can take the readings. Okay, so before you put your solution, you have to adjust the 0. Okay, before you put your solution tube, you have to press it, and you have to assure that there is a 0, and then you put your reagent and take the readings, note down. So this is all about digital photometer. As I told you, there is a light source, after that there is a filter, and there is a cuvette, and this cuvette of solution will absorb the light, and remaining light will fall on photocell, which will give you the readings. So this is the actual inside and outside of colorimeter. I hope you understand this. If there is any question, you can feel free to ask it. Thank you so much.